Hey everybody, this is the video on solving equations with fractions. So let's start off with this first question here. We have x minus 17 over 3 equals 20 over 3. I want to isolate x. I want it all by itself, and so I'm going to do the opposite of what's going on, what's happening to it. So I'm going to add 17 over 3 to both sides. What ends up happening here is 17 over 3 and minus 17 over 3 cancel each other off, leaving us with x all by itself. Then we have 20 over 3 plus 17 over 3, and they both have the same exact denominator, so we can add them up, and we end up getting a 37 over 3. And you guys can leave it in fraction form. Okay, so for our next problem, we have negative 3 over 5 times d equals negative 9. And we want to isolate the d. We want the d all by itself. So we want to think about the opposite operation. How can we get rid of that negative 3 over 5? I'm going to multiply by what's called the reciprocal. That means the flip of this denominator here, the negative 3 over 5. So we're going to multiply by the flip of that, which is a 5 over negative 3. And we do that to both sides. What that does for us is that gives us a 5 over a 5, which cancels. And it gives us a negative 3 over 3, which cancels. And that leaves us with the d all by itself. And now we have negative 9 over 1 times 5 over negative 3. So we can think about this in two ways. We can think about this as negative times negative is positive, and we got a 45 over 3, which is equal to 15. We could also think of it this way. We have 9 divided by 3, which is 3. We're left with a 5 to multiply to get to that 15. Either way we look at it, we get a 15. Okay, so for our next problem, number 3, we have 8 equals 2 minus negative 2 over 3m. So first thing we want to do is isolate the term that has the variable, which is the negative 2 over 3m. So we're going to do the opposite of adding 2, which means subtract 2 to both sides, and that gives us 6 equals negative 2 over 3m. And so just like our last problem, we're going to isolate the m, get the m all by itself by multiplying both sides by the reciprocal of the fraction next to the m, the coefficient. So we're going to multiply by 3 over 2, negative 2. So 3 over negative 2. That crosses the 3's, crosses the 2's. We're left with m all by itself. And so we have 3 times 6, which is 18, over negative 2, which is negative 9. But remember, we can also think about this as 6 divided by 2, which is negative 3, times the 3 that's there, giving us the negative 9. Once again, either way gives us the same number, negative 9. Okay, so number 4, we have negative 2 over 5 plus m equals negative 1. And we want to isolate the m. We want the m all by itself. So we're going to start off by doing the opposite of what's happening to that m. We're going to add 2 over 5 to both sides. These guys cross, and what we are left with is m equals 2 over 5 minus 1 over 3. We want to subtract, but we can't right now because we don't have a common denominator. So I'm going to multiply 2 over 5 by 3 over 3 because that's what the other denominator is over here. And I'm going to multiply that negative 1 over 3 times 5 over 5, which is the denominator over here. What that does for us is that gives us 15 in the denominator for both fractions. That enables us to subtract. And what we end up with is a 1 over 15. Okay, number 5, we kick it up a notch. We have 3 over 4m plus 2/3 equals negative 5/6. And what we need to do is solve for m, but we first need to get to the m all by itself, the term with the m. We first need to get the term with the m all by itself. So we're going to start off by subtracting negative 2 over 3 to both sides. And we end up getting 3 over 4m equals negative 5 over 6 minus 2 over 3. And once again, we need to get a common denominator over here on the right. So I could see here that 6 is made up of 2 times 3. 2 times 3. And I want the same denominator. So essentially what I'm thinking is I need that 2 over here. And I can't just multiply to the bottom. I have to do bottom and top because that's really a 1. I'm multiplying by 1. I'm not really changing things. So that will give us same denominator. So from here, we can combine the numerators and we subtract minus 5 minus 6 gives us a minus 11 over 6. So we need to isolate the term that has we need to isolate the variable itself, the m, and so we have to do the opposite of what's happening. We have to multiply by a 4 over a 3. Do the opposite, multiply by the reciprocal. So that ends up crossing off the 4 over 4 and 3 over 3. And we are left with, this right here. I multiplied across the numerator and denominator. The way I'm going to simplify this, I'm going to break up the 4. And then I'm going to break up the 6. And what that does for me is I can cross off some of the same factors in the numerator. And, well, that's it, actually. So I'm left with negative 11 times 2 over 3 times 3, which is 9, which is the final answer. Okay, so for our next problem, we have to, gosh, we have a lot to do here. We have to combine terms with x to start. So let's look at the left first. We need to get a common denominator. So I'm going to need to multiply the right side by 4 over 4 and the left side by 5 over 5 to get a common denominator of 20. Okay, so by multiplying left and right fractions here, we end up with the common denominator of 20. And then we can combine our fractions together. We have a 16 minus 15 is 1 over 20x there. And then on the right, we have 3 over 10x. We're going to have to combine those terms with x together. I'm going to need to subtract 3 over 10x to both sides. Show you what that looks like in a moment. Okay, so at this point, we need a common denominator with our x term. And so I see 20 in the denominator on one, 10 on the denominator on the other. And I know that 20 is made up of 2 times 10. So the thing I got missing over here is the 2. I got to multiply top and bottom by 2 so I have the same denominator. That gives me a 1 over 20x minus 6 over 20x equals a minus 1. So we got the same denominator now, and we just have to subtract 6 from 1, which gives us a minus 5 over 20x equals minus 1. So let's solve for x by multiplying by the reciprocal, 20 over negative 5. And that gives us these guys crossing off, and we're left with x all by itself. Negative negative is positive, and 20 divided by 5 is 4. All right, boys and girls, we got another long problem here. It looks similar to the last one. In fact, is it the same problem? No, it is not. So I'm gonna jam through this one with you guys. I'm gonna go real fast on this one. So I have to combine the like terms on the left here before I start solving. And I see I have a 10 here, so I'm going to multiply this left fraction by a 2 over a 2, which is going to give me a 10 and a 6 there. So 6 over 10. So 6 over 10k minus 1 over 10k is going to give me a 5 over 10k, which is equal to 1 over 2k plus 1. So right away I can see here that 5 over 10 can be simplified to 1 over 2. So we have 1 over 2k equals 1 over 2k plus 1. And so if I subtract 1 over 2k both sides to get my terms with k all together, then I end up with some really interesting stuff here. These cross off, and I'm left with 0 equals 1. And I'm like, huh? That's weird. 0 is not equal to 1. Ooh, that must mean there's no solution. All right, guys, last question here. Got some correct. First thing I noticed on the left, I have to get rid of those parentheses and just put it in. Now, this is 2 over 3. This is 6x over 1. We have a 2 times 6 is 12 over 3x, and then 2 times 3 is 6, and that's over 3 equals 4x plus 2. And some of you saw, oh, 6 over 2, 6 over 3 is 2 times 2 is 4, 12 over 3 is 4. So saw it differently. Some of you saw 3 over 3, which cancels, leaving us with a 2. Or you could have saw the 6 over 3 is 2. So from here, we end up with something interesting here. We end up with the same thing on both sides. What that tells me is no matter what I plug into the left side or the right side, whatever I plug in here for x, we're going to get the same thing no matter what on both sides. And another way of looking at it is if I were to subtract 4x and 2 to both sides, I end up with 0 equals 0, which makes lots of sense.